Hello everyone, in this video we'll be solving problem 290 word pattern. The problem statement is given a pattern and a string s, find if s follows the same pattern. Looking at example number 1, if we try to find the pattern between the two strings, each a is represented by the word dog while b is represented by the word cat. Because it is following the pattern, the output is true. In example number 2, the pattern is not consistently followed. A is represented by the word dog and fish at the same time, hence the output is false. I hope you were able to understand the problem statement. Let's switch to whiteboard and discuss what are the potential solutions. One simple approach to solve this problem is using Hashmap, where we'll create a key value pair between the character and its corresponding word. And during the iteration, if we encounter a word that does not match the corresponding value in the hash map, we'll stop the iteration and return false. If the pattern is not broken until the end of the iteration, we'll return true. For example, if we start the iteration with I is equal to 0, we are looking at A and the word dog. As it does not exist in the hash map, we'll add it. And if we encounter the character A again, like at index 3, we have to make sure that the corresponding word should be dog. If it is not dog, then we'll stop the iteration and return false. Similar to A, we'll have another map entry for character B, and the corresponding value will be cat. This approach solves the problem if we are doing one directional checks, but there is one case that it will not be able to capture. Let's assume that we have one more character in the string E and its corresponding word is cat. If we continue the same approach where we are checking the characters to its corresponding value in the hash map, this will still be valid. But if you look the other way around, the word cat is being mapped to two separate characters, that is B and E, which makes it invalid. Considering that scenario, we need to make sure that our solution is not doing just a one-way check, but we are also able to verify if the corresponding word is represented by the same character consistently throughout the string. The simplest approach is to use two hash maps, where the first one will be maintaining the map between character to string, while the second map will be maintaining the collection between string to character. So when we start the iteration, we'll make sure that the pair of character to string is being added to both of these hash maps. And as we continue with the iteration, we'll make sure that the pair of character to string is consistently followed by comparing it against the two hash maps. Let's do a couple of simulations to understand how will this solve our problem. Starting with I is equal to 0, we are pointing at the first character A and the corresponding word is dog. We'll first check if it exists in both of the collections. It does not exist, so we'll add to both of them. After incrementing our pointer, we are looking at B and the corresponding word is cat. We'll again check if it exists in either of the two collections. It does not exist, so we'll go ahead and add it. After incrementing our pointer to 2, we are looking at the character B and the corresponding word is cat. Does this exist in the first one? Yes, it does. And the value matches to what we are looking at. And the same applies to the second collection, where the key is cat and the corresponding value is B. Both of these pairs match, so everything is good. So we can continue forward. The same will happen when I is equal to 3. We are looking at the character A and the corresponding value is dog. Everything is going to be good because it exists with the right value. With I is equal to 4, this is where things get interesting. The character is E and the value or the word is cat. We'll check if E exists in the first collection. It does not exist. We'll check if the word cat exists. It does exist and its corresponding value is B, which does not match to the character that we are looking at. So we'll stop the iteration here and return false. With this solution, our time complexity is O of n, as we are iterating through the given input once, and the space complexity is O of 2n, because we are using these two collections to maintain the map, which can further be simplified as O of n. I hope you are able to understand this explanation. Let me show you how we can implement this using C#. Here is the C# solution. I start by splitting the input string into an array using space as the separator and compare the array length to the pattern string's length. If they are not equal, we return false. I then initialize two dictionaries to maintain the map of the key value pairs, starting with a for loop with I pointing at 0 all the way to the end of the string. Next step is to check if the character that I is pointing at, does it exist in dictionary 1 or the word exists in dictionary 2. If either of the conditions are met where it does not exist, it means that we are encountering that key value pair for the first time, so we'll go ahead and add it. If either the character or the corresponding word exists, the code will go inside this else condition. If the character or the word exists in the dictionaries, then we compare the values. If the value are matching, then everything is good. But if not, then we return false. We do that with dictionary 1 and then repeat it with dictionary 2. If the for loop completes without any failing checks, we return true. This code, when submitted on LeetCode, beats nearly 23% of the submissions in terms of runtime and 48% in terms of memory. Thank you for watching this video. I hope you were able to understand the explanation. The link to the code is available in the description below. Feel free to check that out, and I will see you in the next one. Thank you.